Okay, I think it's time, so let's getting started. So hi everyone, I'm Rico Lin. I'm from Vexxhost. I'm a cloud OpenStack engineer there. And so represent of the company in Canada. Welcome everybody to Canada and hope you have a nice trip here. So today I would like to share with you a topic that myself feel excited about. Have you ever went to a session that the engineer itself feel like excited about the topic and want to share to you? Like he might talk too much. Well, I'm those kind of people. So if I talk too fast or too much, forgive me. So yeah, today is shares about a tool. It's very important for us. It's called Atmosphere. That's what we use to deploy the clouds. So first thing first, the Vexxhost is a public cloud provider. We have 3 data centers in Montreal, in Santa Clara, and in Amsterdam, which is Europe. In Montreal is the biggest one. That is also our headquarters. We also have a lot of private cloud customers which do on-premise and hosted private clouds. So you can imagine like what we manage is dozens of clouds. If I say like, yeah, we love Atmosphere, but yeah, no, we only use it in one test environment, then you will just jump up and leave. I don't want that. So let's do a quick say, we put it almost everywhere. So Atmosphere is very important for Vexxhost. It's our new thing, it's our major thing, it's the one that we really love. We put it all the public clouds everywhere. It's not like a second backup solution. It's the only solution we have. And we keep using it, keep doing the one generation by one generation, one release by a release. So keep using the Atmosphere. And almost all the private clouds we have nowadays also using Atmosphere. It depends on how the customer feels and how their upgrade schedules. But whenever we can recommend, we definitely recommend them to move to Atmosphere. So I guess it will be nice to give you a few backgrounds about our knowledge base. So Vexxhost start with using Ansible for early days. So we're using Ansible to deploy OpenStack and SAP. Ansible is a nice tool, so it wrapped up nicely. About 4 or 5 years ago, we start to evaluate the power of using container. So we're moving into container and we run it on top of Kubernetes. The container we use using Containerd. That running well as well. That gives us a very dynamic tool, I would say very stable clouds. OpenStack itself, a community doing a good job because we make everything so decentralized. So we don't. Every service can put in their own container. So if you are also part of the OpenStack community, you can like pack your bag. You're doing a good job. Me too. Yeah. just want to take the credit. But we need a new state management as well because, as I mentioned, we have a lot of clouds. It's not like only one public cloud. In public cloud, we have 3. In customer, like private cloud, we have more, way more. So we started looking for solutions in that scenario, in the Kubernetes management scenarios. And we started using Terraform. And we use Terraform state to manage the state for our clouds. Now, Terraform is a very powerful tool. A lot of people like Terraform. I love it as well. I do it to deploy some of my own applications as well. But what comes to Terraform is, by design, it do a lot of immutable approach to architecture, which in cases like us, we have different clouds, right? And different clouds, the user have different needs. And also, we are not the only one get to control those clouds. The hardware might malfunction, the user might interact because there's their clouds. And also there are maybe other issues in the cloud. So the cloud status is not stay there forever, right? At a certain point, you have to upgrade. You might need to migrate, but you have to do a lot of things with the clouds. It's not stay there forever. So it becomes a little trouble for us a little problematic when you use it because it's not our scenario and it's definitely not our best way to store those stateful and stateless states. So we started looking for other solution in the pool, and we start to adopt OpenStack Helm. By all the stats I put down here, we're not just like validate and see if we want. All the state here is actually the stat that we implement the deployment tools, we ship to the customer side, we change our public clouds. So you can imagine like how many migrate of our clouds and the customer clouds. So we do a lot of things to make sure the customer is happy. Well, Muhammad did a lot of things to make sure the customer is happy. I'm pretty sure he's here somewhere. So yeah, we're using Helm. So Helm is a very nice tool because it gives us Helm resources, right? And Helm resources is perfect running on the Kubernetes because essentially same community. And also OpenStack Helm project itself is more like a toolkit. It provides very nice toolkits for us to build the charts because we're not just using OpenStack Helm, we're using other Helm charts as well. We need to develop our own Helm charts as well when it comes, and we need to do some upgrade about the charts. There's one layer that might a little bit missing is the. So when you're using OpenStack Helm, is essentially the repository itself is essentially just a toolkit. You can treat it like a tool. But you need a more flexible way on top to manage the entire variable state and all the processes in order to make sure your deployments in actual production flows, it can go very dynamically. Because like I mentioned, different clouds and different needs. That will help us a lot to wrap it up. And so on, we start to put more things inside. The build images, the workflows, other script. So it becomes the Atmosphere project we have. I'll try to demonstrate later on how that can be used, right? So yeah, Atmosphere, an open source project. You can download, you can use it, you can run by yourself, and you can report a bug. And best if you can, like join us, help developing it, would be really nice. We start to see the people's providing their fix. That's like what we feel like, woohoo, right? So we want that. We want that a lot. So welcome everybody. So if by looking a little bit on the structure, it just the Ansible is the major one, right, on the outside. Atmosphere 2 is essentially the up layer part. It is using Ansible to deploy Kubernetes and step on top of nodes, and trigger Helm to deploy OpenStack and Prometheus, which is for alert manager. And on top of OpenStack, then you, like what you saw in Keynote, you can build a Kubernetes cluster. You can build VMs, of course. You can also you can build a bare metal with OpenStack as well. One thing you might notice is Atmosphere as a project, we didn't put hardware, like how to deploy from hardware. It wasn't there in Atmosphere. For now, it's made for purpose because as nowadays the clouds start getting overwhelming. A lot of the new tools, there's even AIs on the road. So we need to do things quickly, and we need to migrate very fast, right? The new version of Python, the new version of operating system is so fast. So what we do is we do the down level over the hardware and operating system is need to install by yourself. You can use we use Mars. You can use other tools, and we did that. Give us very big advantage on. So we develop Atmosphere like very fast. We don't have any hardware lock-in to say we have to test on specific hardwares, and that also gives us an advantage when it comes to real deployments. The down layer hardwares need to be extra careful. Have you ever like tried those all the way deployments, and you deploy everything up, and it turns out there's a hardware missing and hardware issues, misconfig, but you didn't notice because the cloud installed successfully. I mean, that's really painful when you have already shipped the cloud to the customer. So that will be one thing that Atmosphere here is not covered. But to think of this way, the nodes itself is not that hard to configure. You just have to make sure the hardware is correct and build the operating system on top. It doesn't matter that much what operating system you put. We put usually Ubuntu's, but you can pick your favorite. This is the architecture diagram might look like. I'm not going to dive in deep on this one, but I just want you to know that all the green, all the green part are running inside containers, inside Kubernetes. So there, you see there's actually most of the services, like essentially this, the OpenStack architecture, they're mostly inside the Kubernetes. The VM outside, of course, the self storage outside as well. So that's why the entire Kubernetes OpenStack stuff started kicking, because everything's running on top. The nodes and the requirement for the nodes physical nodes start to getting not that limited to what we do on top. So yeah, I guess we can back to the major topic today is why we need it and why we want it, right? So I think the first thing to say is, I say it's easy to try and work on. So let me give you a demonstration here. So there. So this is a brand new environment. I just this is what I do on top is install the pipe, install a poetry, a library that is using for packaging, the dependency for packages, for test environments, and git clone the Atmosphere. That's it, okay? And we put an OpenRC in the environment. What we're going to do with it is because, as you know, Atmosphere didn't include on like building hardware for you. So Atmosphere have a very nice way to build a test environment for you by access to OpenStack APIs. What it means is to create a heat stake to build an environment for you so you can test on. So that's why we need an OpenRC file. If you don't know what that is, it's username, password, and your authentication info to the OpenStack cloud. Actually, you can point to any OpenStack cloud that can be used, right? So let's install the dependency first. And notice like I run it for developing a lot. What you might notice is you make sure your OpenStack clouds, which you're going to test on with Atmosphere, you will set up like 3 controller, 2 compute, and 3 storage nodes. Just make sure you have the resources for those. Depends on how big and how fast you want the test environment to be, right? So all the dependencies are installed. So what we do now is it too small or is it okay? Good? Thanks. Thank you for having good eyes. So yeah, poetry to run Molecular. Molecular is a tool, very nice for Ansible testing. What it do is we have some Ansible script inside. I will show you later. So it basically helps you to set up the environment, test your Ansible projects, and then there's a way to destroy. So if you see the process will be to have the dependency install, create, prepare, and converge. So the dependency was installed with poetry, right? What the first step to create the stack is at Molecular default creates. That's the first step you saw. So the default is because we didn't specify which test environment we want to build on. So this is just to set up a heat stake, and you can provide an instance type by yourself. So if you have like specific type, if you want the cloud to run very fast, stay like real fast, you can just give it extra resources. The install process on top will go like crazy fast. So if you check in the cloud, the public cloud I'm accessing to, so it start to create atmosphere stake. And in the stake, sorry. So you'll see the server, the instances start to kick in, right? It set up 3 controller, 2 compute, and 3 storage nodes. And notice that the name of the node, the CTO, controller 1, controller 2, 3, KVM 1, 2, those are meaningful. I will explain to you later. So mentioned when the molecular, the next will be just to prepare for masquerade rules for your network, and then the major part is to run the site playbook. So inside the site playbook, here, notice this is exactly the entry point for production side as well. Now, all the step before is to make sure you have test environment so you can spin up and use the nodes there to test the atmosphere. Now, from here is exactly what we run at production side as well. It's just to calling those playbooks. The SAP, the Kubernetes, CSI, and OpenStack. And let's pick OpenStack to look into. For example, it will just like include a lot of roles. Those roles will also define it in our project as well. Notice there's also we put a take. I will let you know why we need a take there. And if you look at inside the role, it essentially just to do is to deploy the Helm chart. Not that much like magic there. Just Helm charts, create an ingress if needed, and that's actually the major part for it. And prepare, of course, prepare for the config and others as well. But that is not that much work. Just majorly just to use the Helm charts. So I think that will be the first to easily try and work on, right? And also, yeah, to build an environment with like just random standard resources, you probably need like an hour or an hour and a half if your cloud's slow. If you want it really fast, just give you extra resources. I mean, few like 20, 30 minutes is definitely possible. I don't want to put that much resource against our public clouds because we have customer on top of public clouds. I don't want to anything happen to them. So I will leave the crazy spin-off for them. I'm just an engineer here to play. So here is a ready environment I built. I just want to show you like what happens when it's finished, right? So in this environment as well, OpenRC, that is what's used to install the stake. But now we don't need it. We just need to go back to atmosphere and do, this command, purge run, molecular, login. And remember I mentioned about the controller 1, 2, 3, KVM 1, 2, all the nodes. So you can directly using in here, so you can direct access to your test environment. Of course, you can access outside, not without using molecular, but molecular give you a nice way here with the script we provide inside. So you can just log into. And then there you have a very standard production-ready environment. Nice to show you what OpenRC is, right? You didn't see mine. But this is a OpenRC look like the username, password, authentication URL. And so you can use it. And doing like, sorry, I don't usually use this desktop. Interact with OpenStack, right? And of course, remember we're using SAP, so you can interact with SAP as well. Everything is there ready. The network is perfectly cut because we actually use it for our public cloud source as well. So a lot of things not supposed to be exposed outside. It's not only through the ingress can access to this cloud. That's something very secure. Also, of course, yeah, who don't like to check on Kubernetes, right? Let's check on. Yeah, the part is there, the service is there, all the Sunlink key, Octavia, everything. And if you're running with public clouds or OpenStack clouds, and if you have the address you can access in, you can actually use it to log in to the environments you just built or later built. So there you go, you will have a full ready OpenStack Kubernetes staff environment for you. And if you don't want it anymore, like for example, if I don't want this environment anymore, why not? It's running halfway. The node is running, or it's when it's ready. You can just also do, instead of conversion, you can just destroy it. What that will do is it will clean out all the caches. It will destroy the heat stack. So that becomes a very easy way, because when you don't need the resources, you don't want it to occupy there, and you just destroy it and rerun it, install it when you actually need a resource up or test environment up. Depends on how big is your environment, right? And now the heat stack should be maybe under delete process. Cool. I will also do other feature demonstrate, but if you're really interesting about it, it's really run fast, and there's just single command to install. Really not big magic, but that's very neat because you can run it against any OpenStack clouds. Also, it's very important for us to integrate with communities and our products. So that's why we opened it as a open source itself as well, right? But what this means is also we are not the only open source, right? We use, like I mentioned, we're using OpenStack Helm charts, right? We're using other charts as well. So we inside Atmosphere, if you look closely, we have a lot of places like this. We sync the charts from Upstreams. We don't re-implement ourselves, but we download it here to Atmosphere locally because we need to do offline deployments at certain point for certain use cases. But for example, here will be to have the packages download and to use and sync in the chart. That will rebase our current work in progress charts, and that will give us very nice, because we don't have mess up with the current work in progress charts, but we also keep tracking on upstream charts. We actually run the script very much and fast. Like we sync the chart all the time because we want to keep all the update, all the new features with us. And if you notice, there is like, you can also using review link. So what this is, we recently contribute the Manila charts for OpenStack Helm projects. And if you check on this, the patch, that will be exactly this one. So yeah, it's a work in progress patch. The community not yet accept it, but it's very important for us and for our customer and for whoever using Atmosphere, I think. So that's the process that we have, like this kind of a community buffer. A lot of things we contribute to the communities, but we don't want it to slow down the customer side or our public cloud side. That's where we start to like make sure we have a buffer, and we, at long run, we will keep pushing on the communities. And eventually, when it merged, we just change the versions for the charts, and we will resync it down. And of course, you can do the similar thing to the image as well. Right now, Atmosphere run with that release. I hope that's advanced for you enough. But if you have any like test patches or any thing you want to test, it's very similar to that. You just repoint the images to other places. So we have other workflow. I don't have time to like go to very deep, but we have other workflow like this. For integrate and customize. For integrate is very simple to explain. We put everything inside. Everything we run in public clouds. We didn't hide all the stuff. Like other managers is there. The way we tune the config is there. Like if you check on, let's check on this. So like this is a learn setup in the with permissions in our clouds, right? And all these are actually using in our clouds as well in a lot of places around all the clouds we have. And customizable. If you check on all the Ansibles, like what I mentioned, the images you can replace. Like here, we comment out like designate because it doesn't make sense to run it everywhere. You actually need specific config to have it. So we comment out, and what you can do is, for example, if you're running for a small scale of testing, you can comment out a lot of stuff, right? You can comment out half of the OpenStack, or you don't want the OpenStack, you can just run the SAP and Kubernetes and comment out those in the Ansible playbook roles you have. Then the cloud will went very fast because you just install SAP or Kubernetes. We do that a lot of times in actual deployment on cloud environments for customers because sometimes if there's any specific needs, you need to like step a point that you have to stop. So like you install the SAP and Kubernetes, and you want to check around to see if the cloud is, healthy and the hardware is good. So you have a better confidence to go to the next step. I don't know about you guys, but in the old times I have experienced that I have to run all the way to the deployment. If you fail at any point, you have to go back to the first. And that's very horrible when you're trying to tell the customer, say, hey, sorry, we're trying to upgrade your clouds, but it fails. Do you want to us to provide you a new cloud? We didn't do that because we had atmosphere. Whoosh. Okay, so let's also talk about long-term. I think the why is also about long-term maintain and upgrade. So I'm going to give you a very quick showcase on how to upgrade with the test environment proposed. So yeah, let's get back to the test environments. Who we want to pick for victim? Yeah, Marita, why not? Var. So what if we have just like one APIs? What could go wrong, right? What we'll need is so yeah, no magic, just the same command. You run with molecular, the same command. Then what it do is you will check on the entire script. So it will pick out where you did the changes and reinstall on your environments again. Because with Kubernetes, there's rolling upgrades, so it depends on what you change, right? But usually not a big deal to your clouds. But what you can also do, just using the tag. Remember when the roles comes in, we have tag there. So you just add a tag with Molina, and that will do is it will just pick up. You will build the variables you need and just run the Molina part. That works in the production side as well. You don't want to update the entire clouds, just want to update the Molina, right? For long-term maintain, it's hard to explain. Like how can I stand here and say, yeah, we're doing long-term good, unless we lock the door and put everybody here like an year. I mean, we have another water and, right? We have? No? Okay, fine. But let's not do it. So is that good with atmosphere, right? I think that's the point, right? Before we jump into that, let's show you. This is, again, a Helm workflow. All the monitoring is all there in the atmosphere open source. So you can use it. So what it do is in monitoring all the pods that make sense to the clouds. Like, at least it makes sense to us and all the dozens of customers and also our public clouds. And you point that to Teams or Upstream or Slack to get the alerts. So we get alerts from all the clouds whenever needed, and we have all the times we have people need to go in and fix and check on the warnings, maybe out of IPs. So this is the diagram. So compare April and May, 2 months period. Compare 2022 to 2023. with all the works we did with Atmosphere. Like we update the Pythons, we update the a lot of operating systems as well. We retune the network, retune the config, and we got like 20% less. I know what you're thinking now. I mean, Rico, 20% is like, it's okay. It's not impressive, but it's okay. But let me give you another diagram. At the same time, same year, our customer growth, just counting the number, is 40% up. Just the number, not the size. And if you're counting by existing customer with the new clusters, new hardwares, the number go way up 40. So when I say 40, growth is very conservatively speaking. So if you compare the two numbers, we got 40% more up all the resources we need to learn on, but still at the time, we got 20% drop of alerts. I mean, that is, I don't know how you feel, but it's like you make your coffee in the morning, and you put down your coffee, you open your laptop, and do nothing. Because alert didn't come in as usual, because we updated the environments. We do a lot of hardware to do this. I mean, at Atmosphere, the Vexxhost team developing do a very good job on doing it. So for me, that is because all the things that we do here, right? But Atmosphere have other good points and other good say benefit as well. Pros and cons, whatever you want to call. But the best thing you do is to explore about it. You want to see it, just download it. We have a booth here. We're still here. If you can go to the booth, you can find us, chat with us. If you have any interesting public cloud, private clouds, Atmosphere, coffees, you can find us and we can talk. As I'm running out of time, sorry, man. I'm running out of time, so I guess that will be all my presentations. So thank you all be here. I wish to see you all rest of the week.